Very good evening. This is Mohan Raj, Assistant Professor, Department of Mechanical Engineering, KSR College of Engineering. Today we are going to see about flexible manufacturing system. So this is the topic in the computer integrated missions. So now we are going to discuss about a small chapter that is called the flexible manufacturing system. So shortly we can say it as FMS. So it is the most automated technology, sophisticated for the GT sales. So GT means group technology. So we can see about GT later. So FMS, actually it is a small factory system where machines, computers and material handling systems work together automatically to produce different products with good flexibility. So why we go for automations? So these are the reasons for automation. So to increase labor productivity, reduce labor cost, to mitigate the effects of labor shortages, and to reduce routine manual and clerical tasks, and to improve worker safety, to improve product quality, to reduce manufacturing lead time, to accomplish what cannot be done manually, to avoid the high cost of not automating. These are all simple history of FMS. So flexible manufacturing system was first developed for machining operations. But before FMS could be created, numerical control technology had to be developed because FMS depends on automated machine control. So this idea of FMS was introduced by David Williamson, yeah, British engineer in the mid 1960s, and the first FMS system was installed in the late of 1960s at Ingersoll Rand in Virginia. So after this success, many major companies started using FMS, such as Caterpillar, Cincinnati Millarcon, and General Electric. So other countries also adopted FMS, German, Russia, Japan. So almost before 1975, all the countries are adopted FMS. So what is an FMS? So a flexible manufacturing system, or FMS, is an advanced automated system based on group technology. Actually, it consists of a group of machines. So mostly CNC machines. Nowadays, we are controlling by using FMS. Automated material handling system like conveyors, robots, storage systems, a computer controlled system to manage everything. So, in general, we can say the FMS is most suitable for mid-variety and mid-volume production. It is mainly used in machining and works on group technology. So, however, it is not fully flexible, but it can produce only limited range of part families. So, the name FMS, flexible manufacturing system, what makes it flexible? So that is more important. So these following three capabilities that a manufacturing system must possesses to be flexible: the ability to identify the and distinguish among the different parts or product style processed by the system, quick changeover of operating instructions, and quick changeover of physical setup. So these are the types of FMS: processing operations, assembly operations. These operations can be distinguished by FMS to the kind of manufacturing operations they perform. FMS can also be classified by number of machines and level of flexibility. So FMS system can be classified based on the number of machines used in the system. A single machine cell, that is known as SMC, it consists of only one CNC machine or a small part storage system, and a flexible machine cell, that is known as FMC, it consists of 2 to 3 machines, machining or turning centers. So whatever machines they can using this adoption, that is FMS, a metal handling system and a load and unload station. FMS generally it consists of 4 or more processing workstations, common automated manufacturing handling system, distributed control systems. And these are the FMS components: workstations, metal handling and storage systems, computer control system. Even though it is highly automated, people are required to operate the system. So all these components are discussed in the coming slides. So workstations, load and unload stations. So already we discussed about the load and unload stations in the previous videos. Machining stations, other processing stations, assembly, and other stations and equipments. Metal handling and storage system. The second major component of FMS, it is a metal handling and storage system. So function of the metal handling system: independent movement of work parts between workstations, handle a variety of work part configurations, so temporary storage compatible with computer control. So now we are an important area. So FMS layout configurations. So this material system establishes the FMS layout. There are inline layout. So what is meant by inlay layout? So in an inlay layout, all machines and metal handling systems are arranged in a straight line. But in loop layout, machines are arranged in a circular or rectangular loop. So I'll show the exact diagram of loop layout. So this is the machine 1, machine 2, machine 3, and below machine 4, machine 5, machine 6. So there is a circular loop, and B diagram figure shows B. All the machines are arranged in a rectangular loop. So this kind of machines, so we can order machine 1, machine 2, machine 3, machine 4 as per requirement. And beyond inline and loop layouts, so more advanced layouts are used nowadays. These include like ladder layout, open field layout, and a robotic centered cell. So what is meant by ladder layout is it has 2 parallel lines like a loop connected by cross path called runs. So machines are placed along these runs. And open field layout, so it is combination of multiple loops and ladder layouts. So it may include extra paths called sidings. And robot, in the robot centered cell is actually it is machines are arranged around a robot. So robot acts as the central handler. So it is in center. So machines are about the robot. So what are the benefits of FMS? So it can be increased machine utilizations and fewer machines only required, reduction in factory floor space required, and greater responsiveness to change, reduced inventory requirements, lower manufacturing lead times, reduced direct labor requirement, and higher productivity. So thank you.